Hello, students. All right, so today we're talking about extreme values, which is section 4.1. And before you begin this, you might want to get a book and read the red box in 4.1 on absolute extrema and local extrema, and make note of these things. So you probably want to pause, read, and then come back to the video. Okay, when you're back, I would like you to copy down this figure as best as you can. And then if you want to, you can pause. And then when you're done, what we're going to do is we're going to talk about absolute extrema and local extrema. Okay? So, first off, it is important to know that when you are asked for an extreme value, that they are asking for a y value. So anytime they say value, they are referring to a y value on the curve. They are not referring to the x value. Okay, so if we look at this graph has absolute extrema, it has local extrema, and this graph that we have here is actually from A to F is a closed interval. Okay, so I am going to look first at f of A, which is a y value. So here is my point A, and so that means that this is A, comma, f of A. So I'm looking at the y value, f of A. F of A is an absolute minimum. Absolute minimum. Why is it an absolute minimum? If you look at the entire interval from A to F, it is the lowest point in the entire interval. It has the lowest y value, okay, over the entire interval. F of B. F of B is called a local maximum value. Local maximum. Also, in other textbooks, it can be referred to as a relative maximum value. Okay, local and relative, same thing. Okay, what they mean by that is if you not look at this whole interval, but if you look locally around this point here, x equal to b, that this f of b would be a maximum if you look at that small little interval right there. So b comma f of b. That is a local maximum. Now let's look at f of c. F of c is a local minimum or relative minimum. So if you look locally around C, not using the whole interval, but just close by it, it is the lowest y value around C. Okay? If you look at f of D has two names. It qualifies as a local maximum, and it is also an absolute maximum. And also, for absolute, we can also call it global. That means this one is also a global minimum. Why is it a global or absolute maximum? Because it is the highest point in the entire interval. So if you look at the entire interval A to F, it is the highest point. If you look at around D, it is also the highest point. That's what makes it a local maximum. And f of e is a local minimum. For the same reason that f of c is a local minimum, okay, that nearby it is the lowest value. Now you look at f of f, this point right here, it does not have, it is not a highest value or a lowest value. We don't know what's happening on the other end of it, but we know that it is not the highest point because this one is higher, and it is not the lowest point. So there's nothing special about f of f except for the fact that this is the endpoint of our interval. Okay? So now let's talk a little bit about local extrema. Okay? Local extrema can only occur at a critical number. So a local extrema can only occur at a critical number. So that means then we need to know what a critical number is. So what is a critical number? A critical number is x equal to c, where f prime of c equals 0, or f prime of c does not exist. Now, a lot of people tend to forget about the does not exist. Most people remember f prime of c equals to 0, but it's actually both of them together. So it could be either this situation or this situation. So let's look at all our local extremas. If you look back at our graph, local extrema. So I have a local maximum at b, and the derivative would be 0. A local minimum at c, and the derivative of that would be does not exist. I have a local maximum at d, and the derivative of that is 0. And I have a local minimum at e, and the derivative of that is 0. So we have quite a few of these situations, but we have one of that. Either way, a critical number is when your derivative equals to 0 or does not exist. So this is what you can see happening on an actual graph. Okay, for further clarification, look at your definition 6 in the red box in the book. Okay,